Hello children, welcome to the online classes. Today I am going to explain you chapter 1, that is chemical reactions and equation. Here, your first topic is chemical change. A chemical change, as the name suggests, brings a change in the chemical composition of the matter. Actually, the substances which are taking part in a chemical change have to combine with each other. During this, there is an exchange of their constituents and new substances are formed. You may notice few of the changes during a chemical change. See, chemical change cannot be easily reversed. It is a permanent nature. In chemical change, both physical and chemical properties are changed. In a chemical change, new substances are always formed. Few of the examples are burning of paper, wood, change of milk into curd, digestion of food, decay of plants, etc. Next is chemical reactions. Chemical change you can say as the chemical reaction, and you can define it in the same way, that is, during a chemical reaction, the substances which are taking part in the reaction changes into new substances with totally different properties. And the substances which are taking part during the reaction are called as reactants, while the substances which are forming as a result of chemical reaction are called as products. You can observe few of the features during a chemical reaction. First one is physical state. For example, in the burning of magnesium, which is a reactant, magnesium is a metal that is in solid state, and air, oxygen, which is a gas, but the product magnesium oxide is a white powder, means in solid state. Next is change of color. For example, when colorless nitric oxide and oxygen react, a color appears due to the formation of brown colored nitrogen dioxide. Next is the formation of new solid mass, which is also called as precipitate. For example, when colorless solution of lead nitrate and potassium iodide are mixed, a yellow precipitate of lead iodide is formed. Next change, that is evolution of a gas or formation of bubbles. For example, when zinc reacts with dilute HCl, then hydrogen gas comes out forming bubbles. Next, change in temperature. When zinc reacts with dilute HCl, the contents of the conical flask get heated up due to the liberation of heat during the reaction. Next is the chemical equation. Chemical equation is exactly writing of an equation with the help of symbol and formula instead of word to represent a chemical reaction. For example, when magnesium is burned in the presence of oxygen, it will give out magnesium oxide, and we are using symbol of all these elements as magnesium Mg, for oxygen O2, which will give out magnesium oxide, and MgO MgO is the formula of magnesium oxide. Now here you can see in the reactant side, one atom of magnesium combined with two atoms of oxygen to give out magnesium oxide. So if we are comparing the number of atoms of each element on both sides, the number of the atoms of oxygen is not same. Therefore, the equation is unbalanced, and this unbalanced equation is called as skeletal equation, and we need to balance it. And after balancing, we get a balanced chemical equation. So, a balanced chemical equation in which number of atoms of each element on the reactant side is equal to that on the product side is called a balanced chemical equation. Now, I will explain next topic, that is how we can balance a chemical equation. See, most of the unbalanced or skeletal equation can be balanced by following the steps which I am explaining. The first step is we have to write skeletal or unbalanced equation of the reaction. Now, we need to find out how many atoms of each type are on each side of the equation. Next step, now look for an element which is in only one chemical on the LHS and in only one chemical on the RHS of the equation. It is good to leave hydrogen and oxygen because we can balance hydrogen oxygen at the last. Now, what we have to do next step, to balance the element, we need to multiply the chemical species on the side which does not have enough atoms of that type by the number required to bring it up to the same as on the other side. This number which we are placing is called as coefficient. Now we need to look for the next element or species that is not balanced and repeat the same. Here I'll explain how you can balance few of the reaction by giving examples. See, when methane burns in air, that is in oxygen, it forms carbon dioxide and water. Here the first step to write the skeletal equation, that is CH4 for methane plus O2, that is for oxygen. Put one arrow, write down carbon dioxide CO2 plus H2O, water. Step 2, you need to check the number of carbon, hydrogen and oxygen. Here see, only these three elements are present, carbon, hydrogen and oxygen, and their respective numbers of atoms on the two sides of the equation are given in the table. Now step 3, you need to check carbon atoms on both sides. Here carbon is present both in methane, which is LHS side, that is reactant side, and CO2, which is RHS side, that is product, but it is already balanced as both sides one atom of carbon is present. Next step, we start with hydrogen. Now check here, in the reactant side we have 4H, in CH4, but only 2H in H2O. Therefore, to balance hydrogen atom, that is H atom, put coefficient 2 in front of H2O. Now, we have equation CH4 plus O2, put the arrow CO2 plus 2H2O. Next step, we need to balance oxygen. Now check it, we now have 2 atoms of oxygen on LHS side, that is reactant side, but 4 atoms of oxygen on the RHS side, that is product side. Therefore, put coefficient 2 in front of O2 on the LHS side. Now the equation is CH4 plus 2O2, put the arrow CO2 plus 2H2. So on inspection, we find that the number of atoms of each element on the both sides of the arrow is equal. So this is the balance equation. Another example, tin oxide when heated with hydrogen gas, it will give out the metal tin and water vapor, that is H2O. Again here first step, you need to write the unbalanced or skeletal chemical equation, that is SnO2. Sn is the symbol of tin. SnO2 plus H2O, put arrow, write Sn plus H2. Next step, to make a table, write element's name, write number of atoms on LHS side, that is reactant. Next, number of atoms on RHS, product. So write element. Here you can see 3 elements are present, Sn, O and H. On LHS side, the number of Sn atom is 1, and on RHS side also Sn atom is 1. O, LHS 2, RHS 1. H on LHS 2 and on RHS 2. Now, next step, you have to check the number of atoms on both sides. See, Sn appears on both sides, but it is already balanced. Next step, you need to balance oxygen. Oxygen is not balanced. There are 2 atoms of oxygen on the LHS, but only 1 on the RHS of the equation. Therefore, you need to put coefficient 2 in front of H2O to balance oxygen atoms. So, your equation will be SnO2 plus H2 arrow, then Sn and 2H2. Now next step, which is step 4, put H atoms out of balance. Now there are 2 atoms of H on the LHS, but 4 atoms of H on RHS. Therefore, to balance hydrogen atom, put coefficient 2 before H2 gas. Now, check your equation. Here, SnO2 plus 2H2 arrow Sn plus 2H2. Hence, this equation is now balanced equation.